Hello everyone. In this video, I'm going to talk more about Chapter 7 related capacity management techniques and theorems and tools. More specifically, I will be solving this question number 4 in the question set that I distributed. So in this question, you're going to learn more about what capacity efficiency is and what capacity utilization is. So let's get started. Let's jump into the question. So in this question, we do have again a medical supply company, and they manufacture hypodermic needles and other medical equipment. The machine that cuts the steel tubing into hypodermic needles has a design capacity of 6,000 needles per hour, and with a capacity utilization of 85%. And actually, in this company runs 8-hour shifts, and they are able to produce 43,000 needles per day due to some data operational constraints. And the question is, what are their daily actual output and capacity efficiency? Couple concepts that we should remember when we deal with these kind of questions. So number one thing is capacity utilization. Utilization, if you remember, we do have a very similar formula for this one. Make it larger. And let's select the right size. Okay, this is good. And the capacity utilization can be calculated by using actual output and dividing it by design capacity. Okay. So let's see whether we can utilize this information already with this question. So remember at the very last sentence it says, so what are their actual daily output, okay, and their capacity efficiency be? All right, it looks like we do not really know actual output, and whether we can calculate it. If we know the capacity utilization, we can multiply it with design capacity to get the actual output. Let's see whether we do know what our design capacity is. If you carefully read the question one more time, you know that they manufacture hypodermic needles and other equipment, and the machine that cuts the steel tubing into hypodermic needles has a design capacity of 6,000 needles per hour with a capacity utilization of 85%. Well, it looks like we do know that the capacity utilization is 85%, and the design capacity is actually 6,000. This is per hour, and they run 8-hour shifts per day. Therefore, we can multiply this by 8, and this is actually their design capacity, daily needles per day, right? And therefore, their actual output can be very easily calculated. 48,000 times 0.85. This number is actually their daily output. It looks like it is 40,800 needles per day. Okay. This makes sense because if their design capacity by design, not doing any production, they know that they have this number in their requirements that the capacity of the machine should produce 48,000 needles per day. Well, of course, there are certain things that are happening and that are preventing them from using their design capacity to full capacity. Therefore, the actual output turns out to be 40,800 needles per day only. Okay, so we answered the first part of the question. The second part of the question is capacity efficiency. Well, we do have capacity efficiency formula, if you remember. Let's write it down. Capacity efficiency can be calculated by using actual output and dividing this number by effective capacity. All right, so what's the difference between effective capacity and design capacity? This is a very key topic, and I want each one of you to grasp this. So the design capacity is actually by design, without even actually doing any manufacturing. Whenever people design this manufacturing environment, they estimated that their capacity should be 48,000 needles per day. Well, of course, there are some certain things happening every day that are preventing you from reaching the design capacity limits. So that would be like maybe your people are reporting to work sick, or your machines are breaking down, or you are maintaining certain equipment. Due to those reasons, you do go below the design capacity, and that will be the effective capacity. And the way that you can calculate effective capacity, one way of doing it is just dividing it by actual output. Dividing actual output by capacity efficiency would give you the effective capacity. Okay, in this case, we are asked to find the capacity efficiency, and let's see whether, well, actually we just calculated the actual output. Do we know effective capacity? Let's take a look at the question. The question says that they are able to produce 43,000 needles per day due to some daily operational constraints. This is exactly the number that I'm looking for. So their effective capacity should be 43,000, and their actual output is already given to us. Right, and then the capacity efficiency, if you do the math, should be 0.9488. So this is nearly 95%. Well, it looks like they are able to utilize 95% of their effective capacity compared to utilizing their 85% of their design capacity. Okay, that should answer this question.